We just happen to know that it's in the first one. If the user reverses them, that's their problem. Of course, you could do stuff about that, but we're not going to. Now I know how much money I have and when I'm getting it. I already calculated the discount rate over there, the P rate. So here's what we're going to do. We're going to say generalized MPV equals generalized MPV plus. Now I'm going to use that function that I created, simple PV. It already gives you the input structure. The first argument is the period rate, which we call P rate. The second argument is the cash amount, which we call J money. And the third argument is how long, which we call J pairing. They're done. Okay, let's think about what that statement means. Again, that equal sign is an assignment operator. It basically says, you know that function we created, simple PV. Go to that function, provide the P rate, J money, and J pairing that we just calculated as inputs. That function is going to give the present value of that cash flow. So let's say it's $23. Go to general memory in the place that's tagged generalized MPV. Currently, in the first pass, that number is 0. But in future passes, it's not going to be 0. Grab the current value, add them up, add the results back to that, put the result back to generalized MPV. So that this is not an equality operator. If that is the case, simple PV has to be 0, right? It's an assignment operator. You calculate the right-hand side, assign it to the left-hand side. If you use the variable in the left-hand side, on right-hand side, that means use its current value before the assignment. Now, the way we structured this, so first IRO is going to be 1. For the first cash flow, we're going to calculate that PV, add it to 0, we'll get a number. Then it's going to do it from 1 to row count. That's what next IRO means. Next time, by default, those counters are incremented by 1. If it is something different, I'll show you how to do that as well. In fact, let's just be trivial about it. If you want to increase them by 1, just say step 1. Since default is 1, you don't have to write it. But suppose you were going to do it only for every other one. Then you would say step 2. Or if you want to go back, sometimes you start from the end of the list, come to the beginning. Then you start with row count 1, step minus 1. Okay? So it's very flexible. This is completely unnecessary if the step is actually 1, but I'm going to leave it there just for the hell of it. Next time, IRO is going to be 2 because its steps are 1. It's going to go to the second row of the range, grab the money, grab the period, calculate the present value of that, add to the present value of the first one, then go back next 3. At that point, generalized MPV is present value of the first 2 set of cash flows. Calculate the PV of the third, add it to the first 2. Now you have the present value of the first 3. See, it keeps repeating itself. It's a loop. Once next IRO, it exhausts the list. It says, okay, I'm done. It goes to the next line. In this case, there is nothing else we want to do. That's it. We're done. Now we're going to go ahead and calculate that here, because we made this thing simple so that we know what the answer is. Let's see if it's getting the simple case correct. And if you don't remember the syntax, go to fx function, user defined, generalized MPV. irate, I'm using actually the APR, okay? ifreq is the frequency, and icache, come on. What happened to this? Did I lose my spreadsheet? Something weird happened. Oh no, it's there. Thank you. Let's save it anyway. Oh, this is auto recovered. So save as Montgomery. Okay. Well, we already. Oh, by the way, you're thinking giving long names to function may be counterproductive, but whenever you're writing a formula, start with the first few letters. It gives you all the list. Double click on that, you get that. In this case, interest rate, frequency, and these. I could have also named that range, which I chose not to. What the hell is going on? Oh, I may have to name this. Let me see. For some reason, it doesn't recognize the function. Let's save this and come back. Sometimes you need to do that. Okay, the abacus. Right here. In fact, let's calculate the difference between them. It's precisely 0, and I'll show you that it is 0 to a lot of digits. Okay. The way Excel calculates things may not be the same as you do, so all digits after the 15th may not necessarily agree, but that's the limit of the precision you get anyway. Let me see. Actually, apparently it is the same. Yeah. Let's do scientific. Yeah. It's exactly the same. Now, I'm not limited to having all the periods being exactly the same. Okay. So suppose, forget about all of these. You're going to get these cash flows in year 2, 7, 10, and 15. Okay. And let's, I'll come to why that's not working. No, it should be working. Yeah. So this would be poor man's way of calculating that amount, right? In this case, my cash flows are different, obviously. Why are these guys not the same? Oh, who's going to tell me why do you think they're not the same? Look at the formula that I use here. I wanted to segue into that kind of discussion anyway. In Excel, there are two types of references in formulas. One of them is called an absolute reference. Defined names are absolute references. But if you refer to something like A4, that is a relative reference. When you copy a formula that has a relative reference, that reference is shifted. Okay. So in this case, whenever you click F2 on any formula, it shows you on what cells it actually depends on in the visible range. So period rates, time, and cash, fine. Let's do the same thing on the next one. It actually refers to the wrong interest rate. Why? Because it shifted the first argument, that was the interest rate, by one, because I put in absolute relative reference.